Okay. Okay, so I was saying that many big organizations, they hire engineers for doing the maintenance work, including airports, hospitals, and banks, and so on and so forth. Then some of them are involved in research as well to find new ways to improve the solutions for the society. Then project management is again a very vast and big field, and it includes planning, scheduling, estimating quantities, and so on and so forth. So a project manager is responsible to make sure the project is finishing on time and within budget. Okay, and then we have engineers who are involved in collaborative jobs as well, where they deal with people from different departments. Okay. So what type of engineers can we have? We earlier went through a very small list of them, but there are many. Okay, so the first one, obviously, which we are concerned with is the civil engineer. Okay, so what are civil engineers doing? They design and oversee construction projects, okay, any type of construction, and mainly it's construction of infrastructure, okay, and infrastructure involves everything which you see around you, okay, so this board is part of infrastructure, these chairs are part of the infrastructure, okay, these lights are part of the infrastructure. The walkway which you see outside is part of the infrastructure. Okay, so anything and everything which is used for operation of any facility. Okay, to have a smooth operation of any facility, we need the infrastructure. Okay, so anything which helps with the activities in a building, they are all part of infrastructure. Okay. What happened? Okay, then we have mechanical engineers, which, so this infrastructure, there are some examples here, bridges, buildings, roads, and water supply systems. Then we have mechanical engineers, which design and develop mechanical systems and devices, which can include engines, machines, HVAC. Anybody knows what HVAC means? HVAC. You know AC, right? AC? You know AC, right? So HV is heating and ventilation. Opposite. AC is for cooling, right? HV is the opposite of that, heating and ventilation. Okay. So all of these things come under the domain of mechanical engineers. Then we have electrical engineers. Okay, they design and develop obviously electrical systems. Okay, and now we have many things around us which are depending upon electrical systems, right? Okay, for example, all of them, right? Okay, so these all what we have, the tablets and the phones and so on and so forth. Okay. Their core comes from electrical engineering. Okay. Obviously, this is a specialization. All electrical engineers don't deal with phones and tablets and laptops. Okay. But the main field is electrical engineering. Okay. Any electrical system which you see around you, it deals with electrical engineers. Okay, and they also deal with the systems which are for power generation. For example, if you have a dam for power generation, if you have power plants, or if you have solar systems, solar panels and so on. So this all comes under the domain of electrical engineers, and they also deal with power distribution. Okay, so these lights, this current, it's not generated here, right? It's coming from somewhere else. And when it comes from somewhere else, it has to be transferred, right? So this transfer mechanism, this over distribution system is under their domain, and they also deal with the communication network as well. Okay, the communication network, the fiber optics and the cellular and everything. Okay, so this all is part of electrical engineering. Then we have chemical engineering, which deals with the chemical processes. Okay, so if you are, for example, what is the most important export for Bahrain? What is the biggest export for Bahrain? What are the things which is sell outside? Petrol, okay. Anything else? Petrol as well. Aluminium. Okay. So these are considered very, very important industries, right? Okay. Petrol is considered important all around GCC. Okay. So it's not like you go and you dig and you will find petrol and you will put it in a bottle and give it to someone, right? It doesn't happen like this. The petrol which you are putting in your car is not the same which they are getting from the field. Okay. So there are processes involved in which they have to refine the petrol, right? And you mentioned aluminium. Okay. So aluminium again, it's a metal. It's not like I go and I dig and I find the metal and give it to you. Okay. Again, they have to refine it. They have to do chemical processing of it and so on. Okay. So this whole process comes under chemical engineering. Okay. I just gave you some examples, but you can imagine many others as well. Can you give me an example from the field of civil engineering where chemical engineers could be involved? Any industry related to civil engineering where chemical engineers would be required? Yes. Cement. Okay. Steel. Okay. So cement factories and steel factories, they also need the input from chemical engineers because chemical processes are done inside it. Okay. And then we have water treatment plants. We have courses about wastewater treatment. Okay. Later on you will take those courses as well. So water treatment is also under chemical engineers. Okay. Yeah, we designed the system. What? Who will tell you what type of system you need? What elements you need? Who will decide? These guys. Clear? Okay. And then we have computer engineers. You know what they do, right? They make computers. Right? Huh? Okay. So but it's only a small part of their job. Now, making computers is like you are doing something physical, right? You are giving me a physical object. Okay. But now you know that this field is not about the physical objects. It's all about what we have inside that. Okay. So you can have a very small phone, but it can do like a million-job phone. Okay. So designing all those things is also part of computer engineering. Okay, so they also deal with networks, the Wi-Fi networks, the cellular networks, and so on and so forth. Okay, and any other system which they need. Embedded means any system which they need to run their programs and so on. Okay, so this is also part of their job. Okay. Then we have aerospace engineers which deal with the aircrafts, the airplanes. Okay, so they deal with their design and the spacecrafts are also included. Okay, anything which goes in space, anything which flies. Okay, Superman. Okay, so it's all part of aerospace engineering. So they design the system and they design these things and so on. Then we have environmental engineers. Okay, they deal with the environmental effects of our activities. Okay, how human activities are impacting the environment. Okay, we are the problem. Right? No human, no problem, right? There was a video I saw a few days ago. There were no humans, there was the whole world will be green and so on. What to do with that green world now if we are not there? I don't know. Yes? No? Okay. So they work on projects which involve managing the activity so to reduce the environmental impact and pollution control and how to increase the sustainability of the world. Okay, so they work on all these things. Then we have biomedical engineers. Okay, people who cannot decide whether they want to be a doctor or engineer. These people. Okay, they have biology and they have medical and they have Indian engineering. Okay, everything. Yeah. So they apply engineering principles to the field of medicine. Okay, which includes basically designing equipments and devices which are used in medical procedures. Okay, the equipments and devices which are used in medical procedures. For example, give an example. You went to the doctor, right? You have done your test and so on, right? Any device you have seen there? Don't say fan and light. Yeah. Any device which you have seen with the doctor? Yes? Huh? MRI, yes. MRI, X-rays as well, right? What else? CT scan. Okay. So all these come under the domain of biomedical engineers. Okay. They design these devices, they maintain it and so on and so forth to make sure that those procedures are done accurately. Okay. Then we have industrial engineers. They optimize the processes which are happening inside the industry. Okay. We mentioned cement industry, aluminum industry, oil industry. Okay. There is one thing to design the machine. Okay. You design the machine, you install it, it's working fine. Okay. But there is one thing to design the system. Where will you put the machine? When will the delivery will come? When the delivery will come? Where should it be stored? Okay. How many days in advance can I ask the delivery to come? Okay. So this is, they are mainly designing the system, not the machine itself. They are designing the system, how this factory or how this industry will be operated. Okay, how many people you need, what level we will put the machine, and where will be our warehouse, and where will be our storehouse, and what materials will be taken in advance, or what materials we can wait and so on. Okay, so industrial engineers, they design the processes which are happening inside the industry. Okay, so they are more dealing with the management. They are dealing with the management. And then we have material engineers which develop and test materials, okay, which are then used in the manufacturing processes. Okay. Now, we use what materials in civil engineering? Tell me. Cement, steel, aggregate. What else? Water. We drink it, right? Mortar. Okay. What else? Anybody else? Sometimes we use wood as well, right? Wood is also used. Okay. And what is this? Glass. Okay. All these are very big materials, right? Okay. How many of them are natural? Which of them are natural? Which of them? Wood and aggregate. Okay, these are natural materials, right? Okay, the rest are made. Cement is made. Even steel. Yeah, steel is a metal, but as I mentioned, you cannot just use it. Okay, so when they are making cement, there is a whole process, right? Who came to the conclusion that there could be cement and we can use it in this way? And by the way, we don't use cement directly. Okay? It's not like we bring cement and start making the wall. From cement we make concrete. And sometimes with concrete we mix steel. Okay? So somebody studies the material and then they tell us, okay, why don't you make this change in the material and it will be good in this way. Okay? So there is a reason we put steel inside concrete. There is a reason that we mix cement with water to do something else. There is a reason we mix cement with aggregate. Okay? So somebody must have thought about these things. Okay? Somebody must have tested them. What will happen if I do this? What type of material will I get if I mix this and this and this? In what proportion should I mix it? Okay? So I mentioned concrete. So, concrete is made up of aggregate and cement and water. Okay, so how much water should I put? How much cement should I put? If I increase cement, what will happen to concrete? If I reduce water, what will happen to the cement? What will happen to the concrete? Okay, So all these things must be tested before you start using it. It's not like, okay, let us bring the material and we will see what happens. Okay? You're not making bread, you're making breadings, right? So it cannot be based upon chance. Then let us do it and we will see later on. Okay? It cannot be based upon chance. So we need engineers who are working in this field. They test the materials, they test their properties, and they also apply different combinations and they see what will happen if you take this combination or that combination. Okay? And in the end, then they come up with the optimum design. If you want concrete of this much strength, then put these many aggregates and this much cement and this much water. Okay? So it all comes after some testing. Okay? So the material engineers, they may give you materials which are used for manufacturing processes, materials from which you can make your machines, materials from which you can make your devices and so on, or they can be they can give you materials or tell you materials which you can use directly in construction, okay, like polymers and ceramics and so on. Okay, so these are different types of engineers we have. Okay. Okay, so you guys are hoping you will become civil engineers, right? All of you? Some of what you thinking. But don't think. Okay? Yes. Let's leave it now. Okay? You will become civil engineers. Okay? So let us see where do we need the other ones. For example, where do we need mechanical engineers as civil engineers? Where and why would I need a mechanical engineer? Where would I come in contact with a mechanical engineer? Yeah. Like machine, which machine? You may know.
Testing the soil before fructification.
Testing the soil before foundation. So what? By the way, testing is done by civil engineers. And if you say testing, civil engineers do the testing. They should do the testing. Maintenance for machines, yes. Maintenance for machines, yes.
The amount of chemical
Chemical? We're talking about mechanical.
if we are making a generator.
Yes. Okay. So mechanical engineers, they will design their machines, right? But still they need the infrastructure to put these machines, right? Okay. They are saying, okay, we need a big generator, we need a big boiler, and our pipeline should be this big, and so on and so forth. This is what they can tell us. Okay. But in the end, we have to design according to what they are saying. Okay. We have to design according to what they are saying. Correct? Okay. What about electrical engineers? They are upstairs. Inside? Yeah. All electrical systems? For the building, yes. Okay. Basically, we call it electrical, mechanical, plumbing. Okay. EMP, something like that. I forgot. Okay. It's EMP, I know, but I forgot the order. Okay. So whenever you design a building, or whenever you are constructing the building, okay, there is a very important element which is called as electrical, mechanical, plumbing. Okay. So electrical, obviously, the lights, the generators, the fans, the wiring. Okay. So this all deals with electrical engineers. Okay. And mechanical and plumbing deals with the mechanical engineers. Plumbing we know, right? The water pipelines and the motor or anything like this. Okay. And so on and so forth. Okay. So this all comes under plumbing. And then based upon your building, you may have other machines as well in your building. Okay. If you are designing a factory, then your mechanical work will be much higher, obviously. Okay. But electrical engineers, basically design the electrical system of your building. Okay, to design the electrical system of the building, and here your construction has to include that design. Clear? Okay, so when we design the rooms, when we design the stairs and so on, we need to keep in mind from where we will have the wiring, where will we have the openings for lights, where will we have the opening for AC and so on. Okay, so all these are done. Then chemical engineers, I already mentioned it, right? The cement industry and aluminum. Okay, by the way, we use all these materials which we mentioned earlier. Cement, obviously, our main material. Steel, very important material. Okay, I mentioned oil, right? Oil exploration. Okay, so oil exploration, oil refineries are also designed by civil engineers. They tell us the process. In the end, we have to design to have that process happening. Okay, so they tell, okay, when the oil comes, the oil will come from this field. After coming from here, it should pass from a filter. We need to design the filter. Okay, after passing out from the filter, it will go to the refinery. The refinery is 10 kilometers away. We have to design the pipeline to go to the refinery. After going to the refinery, it will be going through this chemical. So we have to design those containers and those compartments in which this process will happen. Okay, so this is where we come into contact with them. Computer engineers, yes. Where do we come into contact with computer engineers? I already mentioned like two, three times that example. Electrical one?
Equipment for survey.
Computer. I don't know. Yes. The IT department does what? They should be fired, right? What are they doing in the construction? Yes. What are they doing? What system? For example, give me an example. What system, for example? Anything like concrete mixer? AutoCAD? Yes. Software. Not our genuine softwares, the specialized softwares, you need to know about them, you need to manage them, you need to use them, and you should know if something is wrong. Okay? Don't trust me, you can go to any computer shop and you can ask them for software. They know AutoCAD because AutoCAD is very common. And we are not the only ones who are using it. Okay? AutoCAD is common in many fields. Okay, electrical, mechanical, so that's why they know it. But if you talk about, for example, we have a software for traffic, okay, or highway design, which is, vision. Okay, so if you, they will not even know the name of that software. Okay, because it's very specialized. Okay, so they don't directly deal with those softwares. Okay, but the general systems where we are using it, okay, the maintenance of the computer systems which are part of the company, they are maintained by them. Okay, which software will run on them, that you have to decide. Okay, and by the way, it's not only your softwares. Okay, the company has to maintain the accounting system as well, right? Okay, we don't know anything about accounting, maybe. Okay, but still the company needs an accounting system. Now it's done digitally. It's not long. It's no longer you put it in everything in the register and so on. Okay, so everything is digital and it is online. By the way, okay. So if I am on the site, I don't have to go to the office and check how much balance I have in my account, right? Okay. And same thing with the inventory of the company. How much material they have in store. At what place that material is stored. Which site is using how much material. This all comes under inventory. Okay. So accounting, inventory, design software, drawing software. Okay. So they need their own system, right? Okay. So these computer engineers then they maintain the system, the overall system. Okay. If something happens with the PC, maintenance of the system is part of their job. They cannot tell you which software to use, obviously. Okay? Yeah, and if as a civil engineer you decide we will make another software, okay, can you do that? Can you design a new software for yourself? Why are you looking at that? He started looking at you. Why? You can? Yes. Can you design new software for yourself? Huh? No? No? Anyone? No? Sorry? Computer engineer will do it, but he doesn't know actual engineering. He will design new software, he says, oh, I have a new software. He said, yeah, I can already do it in Excel. Right? Whatever it happens. Okay. Like you have softwares and you go to the company and they are doing the same thing in Excel. But I've seen reports made on Excel, in Excel. The full report. We had a guy and he used to make the full report in Excel. Everything in Excel. Okay. I don't know how, but he did. Okay. Yeah. We don't have the full, some of us or some of the civil engineers are very advanced in computer skills as well, but that is because of their own interest. Okay, when you will go through the courses, you will find that what we are teaching you is how to use the software. How to use the software. Using is something else, developing is something else. To develop the software, you need more knowledge about the programming language and the platform and so on. Okay, normally this is not our domain. Normally we don't consider it to be our domain. Okay, so then we collaborate with computer engineers. We have to sit with them that we have this problem with the current software we have. How can we solve it? They will solve it, but we have to collaborate with them. We have to work together. Okay, and then okay, aerospace engineers. We don't fly, right? None of us fly, right? Or some of us can. Some of us can fly, right? When you are sitting in the class, you close your eyes and you fly out, right? Even if the doors and windows are closed, you can do that, right? Yes. You are saying something? GPS? Yes. Yeah, it is with them. We use GPS systems, we use satellite images, very common now in civil engineering. Okay. So, especially for the people who are working in the government, the ministries, they use these things a lot. Satellite images and maps, and because obviously they are looking at a very big area, they cannot do it physically. The normal surveying doesn't work. So yes, we collaborate with them for these things as well. They can have their own systems. You can launch your own systems. Okay. Nowadays, not in Bahrain, it's not. Maybe the government is using it, but it's not open to everybody. The use of drones. Okay. There are many countries in which the drones are openly used. Okay. Some of them are using for deliveries as well, right? Obviously not our domain. But you can use drones for surveying. You can use drones for monitoring. You can use drones for, I mentioned earlier, inspection on the sites. Okay. They are already using, it's not here, I should have mentioned it earlier, but they use now robots or whatever you want to pick, whatever. Okay. To do the inspection under, dangerous places. The places where you have, like, it is completely enclosed, and if there is something, nobody can come to rescue you. Okay, so they don't take the chance with the people there, and they use robots and something like a drone, and goes inside and can give you the video and you can see it. Okay, so this is also with computer engineers, but the same thing applies here, that the design of the drone and design of any aerial system which we use, satellite image or something, it comes from there. Okay, and another important part, very, very important part, aircraft, right? Okay, we don't design the aircraft, obviously, but we design what for the aircraft? Airports. Okay, airport itself is a very, very big field. You cannot say I am an airport engineer. Because airport has what? It has a runway, right? Then it has hangars, like the parking space for the aircraft. And then you have the building itself, where you go inside. And you should take it and so on. Okay? That building itself. Okay? And then you may have some bridges for trucks which are coming in and going out. You have the baggage system. Okay? So this whole is the thing which is concerned with them. Not the building part, but the aircraft part. Okay, so this is where we collaborate with them. Environmental engineering is written separately here, but in most part of the world, environmental engineering is considered under civil engineering. Environmental engineering is considered under civil engineering because the main aspects of environmental engineering are what? Construction. Okay. What type of pollution we have? There are different types of pollution. Air pollution, water pollution, and something which I am doing right now, noise pollution. Very good. I think it's noise now. -2. Okay. Water pollution, I already told you, wastewater treatment is our domain. Okay. Civil engineers deal with water treatment, wastewater treatment, and so on. Okay. Air pollution, there are many different reasons of air pollution. One of the most common reasons is, the biggest reason is factories, industries. We design them. Road network, our part. Okay, so we are like dealing with these things. Okay, noise pollution, again you control traffic and factories, and again this is our part. Okay. Then we have biomedical engineers. Then I already mentioned there are some engineers who are dealing with the, okay, I'll quickly finish. So biomedical engineers, design of hospitals, okay, we are involved with that, okay. Industrial engineers, like I mentioned, chemicals and so on, the same thing applies here. Material engineers, we are benefiting from them, right? I already mentioned somebody came up with, okay, we can use cement, or we can use concrete, we can use wood, okay, we should use wood here and concrete there, okay. So this all comes from these guys, okay.